Hello here from the 7th IoT and Oil and Gas Conference in Houston. What is a carbon twin? Why is it a good idea and how does it work? Well, generally speaking, a carbon twin allows you to correctly estimate your greenhouse gas emissions across entire value chains and assets. And why is it a good idea? Because it is not always easy to measure your actual greenhouse emissions gas footprint at scale and continuously, for various reasons, which, by the way, I should do another one on why that actually is the case. But stipulate that it is the case, and then let's look at how a carbon twin might help us to understand our emissions footprint without actually measuring. And to do that, I have a line here. It's a pressurized line with some carbon injectors. I have a solenoid valve and a turbine, and then essentially just some exhaust ports that it's actually like an exhaust stack. And so what I can do is I can run that CO2 enriched air through here and vent it here. And here I have a sensor array from one of our partners, NextView. This sensor array can detect various different gases and measure them in good quantity. So I have a lab setup here that I can use to do this. So I can run this here, and I'm venting CO2 enriched air right here. It's going to go right into these nodes to measure it. And if you come over here with me, you see that on this screen I'm actually measuring the RPMs that I'm getting in my turbine because there is a flow through that turbine. Now, as I measure this, over on my sensor, I get CO2 readings that allow me to measure the CO2 in that airstream very exactly. And using both those measurements that I'm doing in this lab setup and the operational parameters that I'm reading from my turbine, I can now create a model, either doing physics or using machine learning, that I can use to now estimate my carbon flow based on these operational parameters. So now, if I switch this off again, if I take this and take it into the field, where I don't have a sensor and cannot easily measure, I can simply use my operational metrics that I can easily measure because they generally tend to be flows, RPMs, temperatures, pressures. I can use those to now accurately model my carbon footprint. If you follow me back over here again, I want to show you how this actually looks like at a larger scale. And for this we've modeled an entire system here. And you see these highlighted red elements. Those are components in the value chain that are now at the moment operating at a higher emissions footprint than they should. And we know that because of the operational parameters that we can use as proxies. And so you see here that clearly my operating parameters, some of them are outside of the green, they're in the yellow, and as a result, I know that because I've modeled it in the lab, that I have a higher than desired carbon emission on this asset. And then I can, of course, take the necessary remedial action to lower this back down to the desired values. Might that be, I can show this here on the inside action, might that be by a repair, replacement, or other methods. Now to top it off, because now I have this model and I can at any point in time pinpoint my emissions footprint based on my operational parameters, I can now use actual measurements, might that be via satellites or fixed wing aircraft or drone, at discrete times to take validating measurements, compare them to my model, in other words, audit my model to confirm that it operates correctly and take remedial action, i.e. additional training or things like that, if I find a discrepancy. So we have an auditable model that we can use to estimate our carbon footprint without having to go and install sensors on all of our facilities. And that is the power of the carbon twin.